Okay, students, we're going to solve radical equations and inequalities. We have the steps here. Isolate the radical on one side of the equation. That's if there's only one radical. If there's two radicals, you have one on each side of the equation. To eliminate the radical, raise each side of the equation to the power equal to the index of the radical. The index is the root itself. So in this case, it would be a 2. So after we get the radical by itself on one side, if there's only one radical involved, then raise it to the second power, because that was a square root. And with whatever you do to one side, you do to the other side. Solve the resulting equation. Check your solution in the original to make sure you have not obtained any extraneous roots. Remember, the key word in extraneous is extra. We talked about this in geometry a little bit as well. I told you to see it in algebra 2. Okay, so it's an extra root. That's why you have to check your answer. Sometimes you'll have an extra one that does not work. So you must plug it back into the original equation, not into one of your other equations down the line that you've got and worked through, but it's got to go back into the original, and it must be true in the original to work. All right. So you must always check those, because oftentimes you get two answers and only one of them will work. I'm just telling you that. Okay. So in example 1 here, we only have one radical, so we get everything else the other side. We add the 4 across, it gives me 12, and then divide by 2, it gives me 6. Now I go ahead and square both sides, which they didn't show that, they just wrote it in words right here. And that takes off the radical. 4x plus 8 equals 36. Subtract the 8 across, 28. And last step, divide by 4 on each side, and you get 7. Check that. If you're only getting one answer, it's probably going to work. Okay, so we plug it. 28 plus 8 is 36. Square root of 36 is 6 times 2 is 12 minus 4 is 8. Yes, it works on the check. Okay. Now, example 2, we have two radicals. So we have one on each side. Do not bring them both to one side. Okay, you'll never finish doing that. You got to have one on each side. Okay, and it's both the square root, so we're going to square both sides. Okay. Now, the left side's easy. It just takes off the radical, 3x plus 1. But don't forget the right side, I have a binomial here. So when I square a binomial, I'm going to end up with a trinomial. And remember, when I square a binomial, I square the first term, so that's going to be 5x. I multiply the two terms together, negative root 5x, double that, negative 2 root 5x, and then multiply the last term together by itself, plus 1. Notice now I have another radical involved, so I have to get that radical by itself, everything else to the other side. So I go ahead and subtract the 5x across. Okay, well, first off, I look here, and this is a negative 2 here. So I'm going to go ahead and move this to this side, move everything else to the other side. Okay, so I have 2 root 5x, first step. Subtract the 3x across, it gives me 2x. Subtract 1 across, and gives me 0. So now I'm down to that. Now the next step, I'm going to divide by 2 on each side to get the radical by itself. And so I have root 5x equals x. Now I go ahead and square both sides again. And I get 5x equals x squared. And that's a quadratic. What's the first thing you do with all quadratics? Set equal to 0. Subtract it across. So I get x squared minus 5x equals 0. Factor out the GCF, which is x. I'm left with x minus 5. Factor what's left inside the parentheses if possible. It's not possible. Now I set each factor equal to 0. So x equals 0 for that one, and x equals 5 for that factor. Remember, these are called factors. Okay. And that's reviewing your factoring. Okay. So notice anytime basically that we're going to have two radicals involved in the equation, we get one on each side, squared out, and we're going to have to get then another, we'll end up with a radical again and move everything to one side, the radical to the other side, and square it out again, and then solve it. Just know that. So now again, don't forget I checked both at the end, see if they both work. They may not both work. 3 times 0 is 0, plus 1 is 1, square root of 1 is 1. And 0 minus 1 is negative 1. Notice 0 does not work. Now check 5. That's 16. That's 4. That's 5 minus 1 is 4. Both of these give me 4. Okay, so this one does work. So x equals 0 is called an extraneous solution. Okay, extraneous. That's why. Most time with radicals, you only have one answer. So again, we came with two answers, and so more than likely one of them is not going to work. Okay. All right, that is that side doing that. Okay, let's go to the other side. Solving radical equation inequalities. Okay, so now we have an inequality. If the index there is even, identify the values of the variable for which the radicand is non-negative. Solve the inequality algebraically, test values to check your solution. Okay, so again, we want to test values to check the solution. So since this is a negative root, I'm going to move it over to the other side and add this across. Okay. We also know that the domain, remember we did this before when we did graphing square roots, the domain we set what's underneath the radical equal to, greater than or equal to 0. So I have 20x plus 4 is greater than or equal to 0. 20x greater than or equal to negative 4 and divide by 20 on both sides, and I get negative 1/5. So the domain is x has to be greater than or equal to negative 1/5 first off. I can't have any other answers. So that's just, this is domain. Okay. But there might be other things that we have to check for as well. So that's this part right here. Okay, now we go ahead and solve this. Again, since this is a negative, I'm going to move it over to the positive side. Move it over here and add the 3 across. Okay, and then they moved them back to the left side. They should have just left over on the right side, but they still get the same thing. Square root of 20x plus 4 is less than or equal to 8. Now you square both sides. Gives you the 64 there and takes off the radical. Subtract the 4 across. 60 divided by 20, you get x is less than or equal to 3. Okay, so solving this is to say all values x less than or equal to 3. But don't forget, our domain restricts it to x values greater than or equal to negative 1/5. So it's got to be between the two. So it appears that that's the solution. So now test some values. Okay, so we could test one less than it. That's what they did here. Outside of the bound, they did two outside of the bounds, one on each end, and then one in between. Okay, and the one in between, the easiest one to check is 0. If 0 is in between there. So negative 1, that gives me negative 20 plus 4 is negative 16. That's not a real number, so the inequality is not satisfied. So we don't have imaginary answers here. You know, check 4. Okay, 4, I would have 5 minus 8 square root of 84, which gives me negative 4.2. And that is not greater than negative 3. It's less than negative 3, so it's also not satisfied. Okay, remember you're plugging it back into the original. Okay, right here is what you're plugging it back into. It has to be true. So 0, I plug in 0. I get square root of 4 is 2. 5 minus 2 is 3. Is 3 greater than or equal to negative 3? Yes, it is. So that one satisfied it. So again, this is my answer then. So I have to check the domain. Okay, make sure it satisfies that. So don't forget, that's going to be the common errors. People just solve the inequality itself and forget to check for the domain. The domain has to be satisfied as well. The domain and the answer, both satisfied. Okay, so first do your domain so you don't forget to do it. I'm just telling you, step 1, domain first. Then solve. Step 2, solve. Okay. So this is right here is saying find domain. That's what that's saying. Find domain first. That's what that step 1 is saying. Then solve it. as we just did, then test the values. Okay, so that is this side, and that ends it.